So the review for both modules 5 and 12, we'll start with 12 first. The above side-by-side frequency chart represents the amount of traffic accidents in California each day for a year grouped by the days of the week. Okay. Which day of the week has the highest median? So median is always this line. Oops, I wanted a highlighter. Let's pick this. These are my medians. Okay. So which one has the highest median? I'm going to say that looks like Wednesday. And that, let's see, if I go straight across, it's probably about 28 accidents. Okay. Which day of the week appears to be the safest day to travel? Okay. Let's see. The lowest median would be Saturday. Okay. I like Saturday because the lowest median is that day. That might be good. Yeah. I'm gonna go with Saturday. Okay. Has the lowest median. Also, the spread, like here, this is 50% of the data. This is 50% of the data. I don't know. I might also go with look at Sunday, 50% of the data. Still pretty darn close to Saturday. And this part right here is lower than that part. So maybe even Sunday. Maybe Saturday or Sunday. How many outliers altogether are represented by this? So the outliers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 outliers. Okay, true, false. Okay, here we go. Okay. There are always more accidents on Wednesday than any other day of the week. Well, since we don't actually have any of the numbers, like the raw data, we can't actually tell. Some days there are less than 10 accidents in the day. Less than 10? I'm going to erase some of this stuff I wrote. Well, here's 10. Are there some days that there are some below that? Yeah, that'd be true. There are days when there are 0 accidents. I don't see anything down at 0, so I'm going to say false. Number 4. 50% of Saturdays have between 10 and 20 accidents. Well, 20 is here, and 50% of the data is down here. So, go back and read it again. Between 10 and 20. Oh, between 10 and 20. I have to read the question correctly. I apologize. Come on. It said between 10 and 20. So that's all the stuff that's inside the box. So yes, that is true. Most Tuesdays have less than 20 accidents. Tuesday. Well, This is like closer to 40 for Tuesday. I'm going to say that's false. Of 52 Fridays charted, exactly one of them has 20 accidents. Well, I don't know. Because we can't tell exactly which one. Nope, so that's going to be false. There could be 2 right there. There could be 3 on that. Thursday has the smallest IQR. So, what day? Thursday. So which one has the smallest box? The smallest box is Thursday, so that would be true. Tuesday's Q3 is closest to, so let's go Tuesday. Tuesday and third quartile is here, so that's really close to 30. So we're going to go here with 30. Okay, so the next one says, given the two-way frequency chart concerning the student's favorite subjects in high school and which grade they are in. So, we're supposed to fill in the box. Let's get my handy dandy calculator. And there are a total of 855 students. Let's subtract the 560 and subtract 115 and subtract 15. And I would end up with 165. And then for science, I take 383 and I subtract 268 and 10, and I get 105. Okay, so I filled in those. Approximately what percentage of students pick math as their favorite student or as their favorite subject? Well, 855 out of a total of 2,607. So 855 divided by 2,000, nope, 2607. So about 33%. Given a student is a freshman, okay, so we're talking about the number of freshmen. And so that's 906 or 917. Oh, that just came out weird. 917. What is the ratio of freshmen that prefer English? So prefer English, freshmen 232. Okay. So next, we're going to create a conditional relative frequency. Okay, so 560. We're going to take 560 divided by 9. So 5, I'm not going to do it for all of them, but I'm showing you where I'm getting the numbers from. And that's going to be 0.61. And it would be 232 divided by 917. And that would come out to 0.25. If I divided this, it would be 105 over 917, which would come out to 0.11. Social studies was 20. Well, that's interesting, 20 out of 917. And that would be, a lot of kids take social studies. So in the next one, we're doing 10th graders. So there's 115 out of a total of 679. So that's going to get us 17%. And then English, 308 divided by 679. And that's going to get us, 0.45. And then this is 200 divided by, picking the wrong number, 679. And that's going to get us 0.29. And last but certainly not least is going to be 56 out of 679, and that is going to be 0.08. Okay, so then I'm not going to write in all of the rest of them, but for 11th grade it'd be 165 divided by 563. Okay, and that would be 0.29. This one would get a 0.19. This one would get 0.12, 0.40. Okay, and then these next ones, I would take 15 and divide it by the total number of kids, 448, and that would give us 0.03. This would give us 0.94. English is, oh, that's interesting. And the least is social studies. Interesting. Okay, so if you asked a random student about their favorite subject and they reply math, which grade would you expect them to be in? So if I looked at that, the highest one is 9th grade. So I would say 9th grade. Because if you look at it, 9th grade math has the highest out of all of them. Okay? Whereas if I look at, if I was looking at 10th grade, this would be 45%, so that would be English. If I looked at 11th grade, that would be social studies, and English for 12th grade. So if you ask 100 sophomores about their favorite subject, how many of them would answer English? So we're doing sophomores in English. So that's 0.45. And if you asked 100 students, that means that you would get 45 students. What is the conditional relative frequency for 12th graders who like science? 12th graders who like science, 0.02. Use the data from the table and state whether or not there is an association between grade and favorite subject. Yes. There appears to be an association. Okay, so number 3. So here we go. How many basketball players, so we're looking at basketball, were surveyed? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. What is the mean and heights for each sport? Okay, so the mean, so I'm going to take all, for soccer, let's find if I was to do the median first, that's 1, 2, 4, 5, 6, 7, 8, and then I'm going to come from this direction. 1, that's 4, that's 8. I have 3 more. I have 3 more. I have 3 more. I have 3 more. So 72. My median would be 72. My, what is the other one? Basketball. And I'm going to do my median. And if I was to do that, okay, so I have 1, 2, 3. So 1, 2, 3. 1, 2, 1, 2, 1, 2, 1, 2. Halfway in between, I would get 80. So that's 80. So I'm going to add all these numbers up, and I'm going to divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. There are 29. So I'm going to add up all those scores and divide by 29. And I would get my mean to be 72.06. If I was to add up all of my basketball scores and divide by 16, I would get that is 79.75. Then it says calculate the IQR for the height of the soccer players. Okay, so we need the soccer players. We need an IQR for the soccer players. Okay, so we know that 72, 65, 67, 67, 69, 69, 69, 70, 70, 70, 72, 72, 72, 72, 73, 73, 73, 73, 73, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 73. Then we have 74, 74, 74. Goodness gracious, 76, 76, 76, and 78. So if I was going to do this, so again, we're going to do 1, 2, 3, 4, 5, oops, you know what? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So then I'm going to go in 3 more here. I'm going to go in 3 more here. I did something wrong. 65, 67, 3 69s, 3 70s. Oh, I forgot the 71s. Forgot all the 71s. How am I going to do this? Here, let me put all the 72s down here. So 72, 72, 2, 72, 1, 2, 3, 4. And there are 3 71s. 1, 1, 1. Okay, so now let's do this again. So I'm going over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I go in 1, 2, 3. I go in 1. Okay. Thanks. Okay. So 72. Then, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so it's I I have done something wrong on this problem. 65, 67, 1, 2, 3. 70s are 1, 2, 3. 71s are 1, 2, 3. 72s are 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Oh, I'm missing a 74. That's the problem. There we go. I was wondering what was going on. Okay, so that 72 is right in the middle. There we go. So now I have to undo this because now I have to count. Okay, so this time around I'm going to do pink, I think. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then I have 1 and 1. Okay, so it's between here. So I have a 70. So that's quartile 1. And then I go 1, 2, 3, 4. I go 1, 2, 3, 4. I go one more. I go one more. One more. One more. So 74. Okay, so 74 minus 72 will get me 2. And that is wrong. Oh, that's because it's not 72. First quartile is 70. So I'll get a 4. So my interquartile range is 4. And I take that and I multiply it by that. And when I multiply 4 times 1.56, yep, 6. So we need 6 below 70. 70 minus 6 would get us 64. And 74 plus 6 would get us 80. So are there any numbers that are lower than 64? No. And above 70 or above 80? No. Okay. Which sport has the larger standard deviation? You don't need to calculate the standard deviation. Well, let's look at it. Well, do you notice that most of the information is clumped together here? So that means their standard deviation would be smaller. Because this is spread out more, that's why it would have a higher standard deviation. So basketball would have the higher one. If we surveyed 2 more soccer players and their heights were 66 and 82, how would the change the median? Well, didn't you just add, you added one on this side of the median and one on this side of the median? The median doesn't change. Okay, so no change. Then, if every basketball grows exactly 3 inches over the summer, how will it change the standard deviation? It won't. No change, because remember, when you're adding, when you add, no change in the standard deviation. If we survey 1 more basketball player and he's 60 inches, how would that affect the standard deviation? So 60. So that's what, and it's basketball, right? Before I do this, basketball, and it's over here. That spreads the data out 60. That spreads the data out even further, so it's going to make the standard deviation larger. It would be a bigger standard deviation. Okay, the dot plot below shows the number of pets each student has in Mrs. Frizzle's class. The top part represents girls. I better write that because I'm going to forget. And this represents boys. How many girls are in the class? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 girls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 boys. Okay. How many boys have one pet? 1, 2, 3, 4. Is the boys' data symmetrical? We're looking on the bottom. Skewed left or skewed right? Okay. So the tail is on the right-hand side, so that is skewed right or positive. What is the median for the boys' data? The median, I think it's 0. Oops, I didn't mean to hit that. I meant to hit the eraser button. So if I was doing, there's 1 point, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, it's halfway in between this. So that means that 0.5. Is the mean or the median higher for the girls' data? Oh, that's an interesting question. Okay, so if I look at this, is the mean or median higher? Well, let's see. 1, 2, 1, 2. So the median is going to be 1. The mean, because this right here has these bigger numbers and they outweigh a 0, that means the mean is going to be higher. So the mean is higher. Okay, the histogram below shows the scores or percentages of Mrs. Frizzle's class on a quiz. Use it to answer the following questions. How many students earn between 70? So between here, that would be 8. How many students took the quiz in total? So I have 3, I have 8, I have 10, I have 9. So that's 11 plus 19, 30. Is this distribution described unimodal, bimodal, or multimodal? So let's look at it. How many peaks are there? There's only 1 peak, so it's unimodal. How many students earned below an 80%? So that's all of this right here. So that's going to be 11. Because, how do I know? Because between 60 and 69, there are 3 students. Between 70 and 79, there are 8 students. So that's a total of 11. Can we tell what the highest score on the quiz was? No, we don't have raw data. No raw data. Draw the dot plot for the set. So the lowest number is 6. So 5, 6, 7, 8, 9, 10, 11. So I have 2 9s, 1, 2, and then I have a 6, and then I have another 9, an 8, and then I have another 9, then I have an 8, then I have an 11, and I have a 10, and then I have another 8, and I have a 9, and I have another 10, I have another 9, I have a 7, another 9, another 7, and I have an 8. Okay. So then on this one, I need to draw a box plot for this. So are they already in order? 6, 7. Oh, they're already in order. That's nice. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. 1, 2, 3, 4, 5, 6, 7. Oh, can't do that. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this right here is my median. Quartile 2 or your median. So then I'm going to do this, change the color, and I'm going to do 1, 2, 3, 1, 2, 3, 1, 1. So it's halfway in between there. So that means this is 68. So it's going to be halfway in between the 1, 2, 3, 4. 1, 2, 3, 4. It's halfway in between here. Oh, that's 73. Okay, so I'm going to put 64, 65, 66, 67, 68, 69, 70. 71, 72, 73, 74, 75. 76, 77, 78, 79, 80. 81, 82. 82 is my lowest number. 64 is my highest number. 64 is my lowest number. 68 is my first quartile. My median is 71. 73 is my third quartile. I draw a box around this. I draw a line down, line across, line across. Okay. So now I need to draw a histogram. Let's see. So I'm going to go up by, so this is going to be my monthly revenue. Okay. I'm going to go up by 5,000. So 15,000, 20,000, 25,000, 30,000, 35,000, 40, 45,000, 50, 55, 60, 65. Okay. So if I'm talking between 15,000 and 20,000, so 15,000 and 20. So there's 1, 2. Oh, there's only 2. Oh, over here I have to do 1, 2, 3, 4. So there's 2. So I'm going to come here, I'm going to make this, and voila. And then I'm going to come here, and I'm going to do between 20 and 25. There's 2. That was horrible. And then I'm going to do, there's 2 more. And then between 30 and 1, 2, 3, there's 3. And then there's 2. And then we have this one, we have 2 more. And then between 45 and 50, 45, we have 1. /50 and 55, we have 1. And then we have 1 out here. Okay. So on this next one, number 9. We are supposed to look at number 7, this one up here, and we're supposed to describe it. So, is it symmetric? There's a gap. There's this gap right here. But other than that, it's pretty symmetric. Pretty symmetric. With a gap between 76 and 82. Okay. Outlier. Well, we didn't figure that out, so let's figure that out. So 73 minus 68. What is this? Okay. 1.5. You multiply that by 1.5 and you get 7.5. So 73 minus 7.5. 73 minus, oh really? Minus 7.5 would get us 65. So there, what did I do? 68. Oh no, this is plus. That's what the problem is. This should be plus. That's why. 73. Why am I using a calculator to do that calculation? 80.5. So 82 is an outlier. Then we need 68 and subtract 7.5. If I did that, I'd get 60.5. So there's nothing below that. So 82 is an outlier. I love how I didn't give myself room. Sorry about that. Is an outlier. What's the median? The median is 71. The range is 18, and the interquartile range is 5. Okay. Then, number 10 says, label the x-axis at 1, 2, and 3 standard deviations from the mean. It tells us the mean is 72. Standard deviation is 5, so I'm going to go up by 5. So that's going to be 77. Up by 5, and that's going to get me 82. Up by 5, that's going to get me 87. Then I'm going to go backwards, and I'm going to subtract. So 67, 62, 57. If 200 students took the algebra test, how many students would you expect to be within 1 standard deviation? So 1 standard deviation is 68%. So we're going to take that and we're going to multiply it by 200. When I do that, I get 136 students. Okay, so now, next, I need to find the standard deviation of this. Okay, so first things first, I need to find my mean. So I'm going to add this up. And so that's 6 plus 12. So that's 18 over 1, 2, 3, 4, 5, 6. So the mean is 3. So I'm going to take, I'm going to put them in order actually. 2, 2, 3, 4, 7, just so that it's easier for me. And so I'm going to take, sorry, I'm going to take the mean. I'm going to subtract the x value. So that's going to get me 3. This is going to get me 1, 1, 0, negative 1, and negative 4. Okay. So then I take those numbers and I square it. And I get 9, 1, 1, 0, 1, 16. And now I add up all these numbers. I divide it by 6. So, let's see. So 9, 10, 11 plus 17. I get 28 divided by 6. And then I take the square root of that. And I get approximately 2.2.